Hi, future GISPs. I'm going to teach you everything that I learned to easily pass the GISP exam so that you don't have to spend years reading textbooks, getting degrees, paying for prep courses, and searching the internet for information like I did. In this video, I'm going to teach you everything I learned about 2D and 3D visualization. 2D and 3D visualization is the fourth section under the cartography and visualization category of the GISCI Geospatial Core Technical Exam list of knowledge categories. Let's get started with section 304, 2D and 3D visualization. 2D mapping. 2D objects have only two dimensions, length and width. A planimetric map. A planimetric map is a map that has no relief data. All features on a planimetric map are 2D features. (2.5D) grid representation. A 2.5D representation is a two-axis grid in which each grid cell or vertex has one and only one z value. (3D mapping). In a full 3D mapping environment, objects or images can have additional dimensions of depth, providing an appearance of volume and realistic representation. Elevation. Elevation is the height or depth of a terrain element with respect to a vertical datum plane. Relief. Relief refers to changes in elevation. (3D GIS data models). 3D GIS data models include vector datasets with z-values, rasters, triangulated irregular networks, multipatch datasets, point cloud datasets, LiDAR data, and digital elevation models. A contour map. A contour map is a map with contour lines. A contour line. Contour lines are lines of equal height above or below sea level. Contour lines run perpendicular to the slope. An isoline. Isolines are lines on a map that connect points of equal value. Iso means equal. There are many different types of isolines. Types of isolines include isobars, isobaths, isochrones, isopatches, and contour lines. Isobars. Isobars are lines of equal atmospheric pressure. Isobaths. Isobaths are lines of equal water depth. Isochrones. Isochrones are lines of equal time distance from a specific location. Isopatches. Isopatches are lines of equal thickness over an area. Isopatches are used in the oil and gas industry. Contour lines. Contour lines are lines of equal elevation on a map that run perpendicular to the slope. Terrain characteristics can be interpreted from contour lines. Slope can be determined from contour line spacing. Closer contour lines indicate steeper slopes. Widely spaced lines suggest gentler terrain. Stream locations can be interpreted from contour lines. Contour lines turn upstream as they approach streams, forming a V shape. Ridges and depressions can be identified from contour lines. Sharp contour points indicate ridges, while rounded contours represent flatter areas. An index contour. Index contours are lines drawn thicker or darker every 5 intervals to make contour maps easier to interpret. A contour interval. The contour interval is the difference in elevation between contour lines. Supplemental contours. Supplemental contours are placed in areas where elevation change is minimal to delineate small features that would be missing without them. Elevation data. Elevation data is recorded in triangulated irregular networks, profile plots, raster datasets, contour line datasets, and in digital elevation models. Extrusion. Extrusion is creating 3D shapes out of 2D shapes. Relief shading. Relief shading uses variations in shades of gray, or dark and light contrasts, that provide a 3D effect by assigning grayscale values representing surface reflectance of sunlight. Hill shading. Hill shading shows the topographical shape of hills and mountains using shading. A shaded relief map. A shaded relief map is a depiction of terrain brightness given a terrain surface and sun location. A shaded relief map is developed from a DEM and a model of light reflectance. On a shaded relief map, diffuse light is scattered by the atmosphere and illuminates shaded areas. The brightness of a cell depends on the local incidence angle. Direct beam light striking the surface at a right angle eliminates the surface the most. Sun location is specified by the solar zenith angle and the solar azimuth angle. Hypsometry. Hypsometry is the measure of land elevation relative to sea level. Hypsometric color. Hypsometric color is coloring or tinting elevation intervals between contour lines. Hypsometric color is also known as elevation tinting. Vertical exaggeration. Vertical exaggeration increases a feature's height to emphasize subtle changes or create a more dramatic effect. A triangulated irregular network, or TIN. A triangulated irregular network represents a surface of connected triangles. Triangulated irregular networks are created from point cloud files by creating the Delaunay triangles. Triangulated irregular networks are good for capturing linear features like roads and bridges. Triangulated irregular networks are efficient at storing data for large homogeneous areas, but are computer intensive to make. Break lines. Break lines occur where the shape of a surface abruptly changes in a TIN. A wireframe model. A wireframe model represents a 3D object with lines. A digital elevation model, or DEM. A digital elevation model is a representation of the bare ground without trees or buildings or other objects. Digital elevation models used to be created from topographic maps. Now digital elevation models are created from LiDAR data. DEMs are produced by the National Mapping Division of the USGS. USGS DEMs are 7.5 minute by 7.5 minute quadrangle maps. Multipatch datasets. Multipatch datasets contain GIS objects that store collections of patches to represent 3D objects. A patch is a 2D shape. The 2D patches are organized to form 3D shapes. A point cloud. A point cloud is a set of data points in a 3D coordinate system. LiDAR data is initially stored in point cloud files. Light detection and ranging, or LiDAR. LiDAR is a remote sensing method that uses light in the form of pulsed laser to measure ranges on Earth. Raw data is recorded in vector point cloud format. Raw data from LiDAR is often converted to raster form for use in GIS. The local incidence angle. The local incidence angle is the angle between the incoming light ray and the surface normal. The surface normal. The surface normal is a line perpendicular to the local surface. Slope and surface direction define the surface normal. The solar zenith angle. The solar zenith angle is the angle between vertical and the sun's location. Solar azimuth angle. The solar azimuth angle is the angle between north and the sun's position in a clockwise direction. Spot heights. Spot heights are exact points on a map with their elevation displayed beside them. A block diagram. A block diagram is an oblique view of terrain that also includes cutaway views of the subsurface. A block diagram often portrays a view along the edges of the map's extent. A Swiss-style map. Swiss-style terrain representation is a style that combines various methods of terrain representation, such as relief shading, contouring, rock drawing, and scree patterns, in a manner consistent with the long-established practices of Swiss cartographers that creates a three-dimensional relief impression. The National Elevation Dataset, or NED. The National Elevation Dataset produced mosaics of the best available elevation data for the United States. The National Elevation Dataset was produced by the USGS. Its primary sources were 7.5-minute elevation data. The National Elevation Dataset was retired in 2015 and replaced by the 3DEP dataset. The National 3D Elevation Project, or 3DEP. The National 3D Elevation Project is a program managed by the USGS to produce high-quality 3D topographic data. It uses LiDAR data. The quality of the National 3D Elevation Project is QL2. USGS topographic maps. USGS topographic maps were first published in 1884. New topographic maps are produced every 3 years. The scale of a USGS topographic map is 1 to 24,000. The extent of USGS topographic maps is 7.5 minute by 7.5 minute. USGS topographic maps portray natural and human-made features within the themes of elevation, hydrography, place names, boundaries, structures, and land cover. USGS topographic maps are georeferenced to NAD 83 or WGS 84 datums and projected to the UTM projection. USGS topographic maps are available in GeoTIFF, JPEG, and KMZ format from the USGS. "3D models. 3D models are highly detailed digital models of physical objects. 3D models are often developed for planning bridges, buildings, monuments, and stadiums. 3D models can use remote sensing or be constructed by hand in 3D design software like SketchUp. Now you know everything that I learned about 2D and 3D visualization to easily pass the GISP exam. Don't forget to thumbs up and subscribe to my channel so that I can keep helping people pass the GISP exam and achieve the rewarding careers in GIS that they deserve. You can also find everything I learned to pass the GISP exam in my book, The Ultimate GISP Exam Study Guide, available on Amazon. My study guide is an easily understandable, comprehensive, graphical, all-in-one resource for passing the exam. You can find the link to my study guide in the description below. Thanks for joining me, and congratulations in advance on passing the GISP exam.